For this experiment, the first thing we need to do is make up the solutions at different concentrations of sodium thiosulfate. So the first one we're going to make is the weakest one at 8 grams per decimeter cubed. The way we make this is by adding 10 centimeter cubed of sodium thiosulfate to 40 centimeter cubed of distilled water. So I've got my thiosulfate here, add it in, and then you top this up with water to 50 centimeter cubed. Now I've marked on with marker to make it really clear where to stop. To make the rest of the concentrations for this experiment, we need to do the following. So for 16 grams per decimeter cubed, we would add 30 centimeter cubed of water and 20 centimeter cubed of sodium thiosulfate. The next one down, 24, we would add 20 of water, 30 of sodium thiosulfate. The next one, 32, we would add 10 of water and 40 of sodium thiosulfate. And the last one, we would add no water, so it's undiluted. It's pure sodium thiosulfate. For this next step, we need a white tile with an X marked on with marker. And onto that, we put a conical flask. Okay, so you can see all the way down it. Now this experiment has to be viewed from bird's eye view. I'll show you why in a bit. So first step, you add your solution that you created. This was 8 grams per decimeter cubed of sodium thiosulfate. You then add 10 centimeter cubed of hydrochloric acid. Okay, this one's 2 molar hydrochloric acid. You could use 1 mole as well. Right, as soon as you put this hydrochloric acid into the solution, you have to press start on the stop clock. After a while, you start seeing this white precipitate forming. The white precipitate is sulfur, the insoluble solid, that will stop you from seeing the X at the bottom. Once the reaction is complete, you won't see the X, so we can press stop on the stop clock. But this has to be done from bird's eye view, because if you're looking at it from an angle, your perception is different. The final result should look like this. Once you get a precipitate formed like this, you need to press stop on your stop clock and record the time in a suitable table. We then need to repeat this process for all the other concentrations that we had. So, in theory, what should happen is that when we increase the concentration of sodium thiosulfate, the reaction should happen quicker because there's more particles available for collision, therefore frequent collisions and a faster rate of reaction. So if we have a look at this, we'll put the sodium thiosulfate in first. This is 40 grams per decimeter cubed, the strongest one. And then we'll add the hydrochloric acid and press start straight away. I'll press stop where we cannot see the X anymore. Now this should happen quite quickly because all the reactant particles should be colliding there. And more frequent collisions would mean the rate of reaction is very quick. So that took just 20.56 seconds on this attempt.